You okay, Cheryl? Great. Let's come back from the break, please. Ms. Katz?
Madam Hearing Officer, we are actually not going to have any follow-up on that last section. So I believe we would be ready to move forward.
Fantastic.
Okay, so then this would be moving to topic 25 on compressor seals. So that the department calls Ms. Keene and Mr. Palmer.
All right. And it's usually Ms. Keene who drives your slides.
Yes.
Okay.
She will be in the driver's seat once again. Let me see if I can check in with her. There you are.
I apologize. I had my volume turned off.
Oh, good. Okay. All right. So this is for the board. We're on section 20.2.50.114, which is compressor seals. This testimony appears at NMED Exhibit 32, starting on page 56, and at NMED Rebuttal Exhibit 1, starting on page 48. All right. And Ms. Keene, do you have the PowerPoint? All right. And I guess I'll just briefly, both Ms. Keene and Mr. Palmer have already adopted their testimony. And Ms. Keene, do you have any changes to this testimony?
No.
And Mr. Palmer, do you have any changes?
I do not.
Okay, thank you. We can move forward. Ms. Keene, can you please give a summary of compressors and compressor seals?
Yes. Good afternoon, everyone. Compressors are used throughout the oil and natural gas industry to compress gas for processing and movement through pipelines. Compressors are mechanical devices that increase the pressure of natural gas and allow the natural gas to be transported in pipelines from the production site through processing and supply chains and ultimately to the consumer. Venting of emissions from compressors occurs from the seals or at wet seal compressors, or alternatively from the packing surrounding the mechanical compression components in reciprocating compressors of the compressor. And these emissions typically increase over time as the compressor components begin to wear.
And can you discuss the rules, emission standards for compressors?
Yes, we are establishing emission standards for both existing centrifugal compressors as well as new centrifugal compressors. Existing compressors must control their VOC emissions from the wet seal fluid degassing system by at least 95% within 2 years of the effective date of this part, while new centrifugal compressors must control their VOC emissions by at least 95% upon startup of that unit. And emissions must be captured and routed through a closed vent system to a control device, a recovery system, a fuel cell, or a process stream. And for existing reciprocating compressors, the requirement is to replace the rod packing every 26,000 hours of operation or 36 months, whichever is later, or collect the VOC emissions from the rod packing and route those emissions to a control device. New reciprocating compressors must comply with the same requirements upon startup.
Thank you. Mr. Palmer, can you discuss the basis for the rule requirements for compressors? You're muted, Mr. Palmer.
Sorry. The compressor seal requirements are the same on centrifugal compressors, are the same as those in the new source performance standards for oil and gas production operations, subpart quad OA. And it requires that owners and operators reduce the methane and VOC emissions from centrifugal compressor wet seal fluid degassing systems by 95%. And the federal rule also requires the wet seal degassing system to be equipped with a cover and closed vent system that routes the gas to a control system or process. For reciprocating compressors, again, the requirements are based on the new NSPS Quad OA, and the NSPS requires the same. It requires owners and operators to replace the rod packing every 26,000 hours or prior to 36 months from the date of the most recent rod packing replacement. And then it requires that owners and operators collect emissions from rod packing and route to a process through a closed vent system. That's if they're not using the rod packing replacement schedule.
Thank you. And Mr. Palmer, can you discuss the emissions, estimated emissions reductions and costs for the rule?
Sure. For reciprocating compressors, we estimated an emission reduction of 5,325 tons per year of VOC from 2,612 reciprocating compressors by increasing the rod packing replacement frequency from a baseline of 4 years to every 3 years. This was the same as the emission reduction methodology is the same as used in the NSPS, and also the 2016 CTG. We estimated the cost of that would be $1,085 per ton of VOC. For centrifugal compressors, we estimated an overall emission reduction of 2,087 tons per year of VOC from 116 centrifugal compressors by controlling them to 95%. And that cost effectiveness would be approximately $320 per year. That may be $320 per ton. So I will check that and have it corrected.
Okay, thank you. Ms. Keene, can you discuss the provisions on applicability and emission standards under this section and some of the revisions that the department made?
Yes, similar to the section 113, where before you is a similar structure of a rule where we have applicability covered in subsection A. The first paragraph addresses centrifugal compressors using wet seals and located at specific facilities are subject to the requirements and exempts centrifugal compressors that are located at well sites and transmission compressor stations from the requirements of this section. Paragraph A2 is the applicability section that covers the reciprocating compressors that are located at those listed facilities, with a similar exemption for reciprocating compressors at well sites and transmission compressor stations. We received several comments from stakeholders, including deleting the section in its entirety, exempting transmission compressor stations from the requirements of this section. The department does not agree to delete this section in its entirety based on the significant VOC emission reductions that were just highlighted. The department did review updated emissions estimates that were provided and did agree to exclude transmission compressor stations from this section based on the very, very limited number of VOC emissions that occurred as a result from those facilities within the process sector or the industrial sector. Paragraph B, 1 establishes the requirements for existing centrifugal compressors. We received a comment to qualify those units to cover those compressors with wet seals. The department agreed with that as it did align with the federal new source performance standard that covers these types of compressors. And so that edit was made. Paragraph B2 then covers the requirements for existing reciprocating compressors. We received a request to strike under negative pressure due to the technical issues around having a negative pressure system around that rod packing system. And the department did agree to strike that and keep that language neutral so that the emissions can be collected and routed, but there does not have to be a negative pressure system installed in order to route those emissions to the control device, recovery system, fuel cell, or process. Similarly, in paragraph 3, which covers new centrifugal compressors, we made a similar edit there with the addition of wet seals to clarify that those are the types of compressors the department intended to include. We also revised the emission reduction requirement from 98 to 95%. That was the department's intent was to require 95% control from those units. Paragraph B4 again covers new reciprocating compressors, and the department made a similar adjustment there. It was striking the language under negative pressure for the reasons previously stated. And then we did strike the requirement to install an emission or an equipment monitoring tag on these units as well.
And can you just discuss the monitoring requirements briefly and any changes made?
Yes, and similar to the reasons provided previously, we have struck the, well, let me start by saying the monitoring requirements again are the monitoring of the equipment and the control devices used in order to demonstrate compliance with the emission standards that are established in subsection B. And so that is the overall framework of the rule. And so what we have before you are all of the monitoring requirements to ensure that there's a method to demonstrate compliance with those emission standards. In paragraph C3, the only requested edit was to again strike the language under negative pressure and replace that language with as designed, which the department agreed with.
And can you review the record keeping provisions and the revisions made there?
So yes, and similar to subsection C, subsection D is the recording of information in order to determine compliance with the emission standards. And so before you are all of the record keeping requirements for both centrifugal compressors, which are covered in D1, and the record keeping requirements for reciprocating compressors, which are covered in D2. These were all minor edits to the language that provide clarification. The department agreed with these minor edits. They did not change the intent of any specific requirement. And so we agreed in large part with all the requests to revise this language. And I can answer any specific questions that folks have, but these are revisions we're clarifying in nature. And this is the last part of the record keeping requirements. So it's a carryover from subparagraph 2 and then paragraph 3 and 4. We did not receive significant comments on this section of the rule. We agreed with the clarifying edits here. There were no changes made to the reporting requirements. And I will just add that the parties are largely in agreement about this section as is. And so we don't anticipate any outstanding issues related to this section. And that's the end of the presentation.
Thank you. And let me just go back to Mr. Palmer briefly. First on the slide, did you determine the correction on that? $320 should have been $320 per ton, not per year.
That's correct, yes.
Okay. And then, Mr. Palmer, were any comments submitted on the tons per year of emissions from compressor seals that need to be clarified?
Yes, we did receive some testimony from other parties indicating that according to the VOC emission inventory, emissions from compressor seals are very, very small, 6 tons per year total per year. That is somewhat misleading because the compressor seal emissions were not a specific item in the inventory in most cases. So in most cases, the compressor seal emissions were probably included as fugitive emissions. Our spreadsheets for compressor seals, based on those, we estimated that the baseline emissions would be about 11,000 tons per year and not 6 tons per year. So they're substantial.
Thank you, Mr. Palmer. And that is all that I have for our witnesses on this topic.
All right, thank you. Do I understand, Ms. Katz, that the proposal from council was on this topic and the next half dozen or so, that we would hear from the parties and then have board questioning?
Correct.
Okay.
But we are still doing cross after each panel of parties. Yes.
All right. So let me invite any party to turn on their camera if they have questions of the department panel. Oh, I see Mr. Heiser.
Thank you, Madam Hearing Officer. I have a question. It's probably for Mr. Palmer, and that is the 5,325 tons per year of savings, I think, that are talked about now. Where did that come from? I was looking through your direct and rebuttal and didn't see that. Is that a new piece of information that the department was able to develop, or where did it come from?
No, that is from the spreadsheets we prepared in July.
The
On the
July
README tab.
6.2 or something, 6 tons, which is why we initially that we didn't think it was worthwhile. So I'm just curious the revision.
Let me give you the exhibit numbers. Exhibit 66 is for compressor seals associated with turbines, which we assumed were the centrifugal compressors. And exhibit 64 are for reciprocating compressors.
Yeah, thank you. That helps us. We appreciate it. Thank you much. That's my last question.
You're welcome.
Thank you. Any other parties with a question? Please turn on your camera. Not seeing anyone. As I understand it, the other parties with witnesses on section 114 include NMOGA, Kinder Morgan, and IPA&M. Shall we start with NMOGA?
Madam Hearing Officer, yes, Justin Lasowski will be our expert. I'm not sure if I got cut off at the beginning of that.
No, I heard you. Thank you.
And I'm back online now. So let me take a moment to share my screen again.
And she's saying, wait.
No problem. I need a second anyways.
I think she says you now can pick it up.
Okay.
All right, Mr. Lasowski, can you say your name for the court reporter?
Yes, Justin Lasowski.
And oh, you can spell it if you'd like.
Lisowski.
Thank you. And just a reminder that you're under oath from earlier today. Have you been asked to present testimony on behalf of NMOGA on compressor seals?
Yes.
And a general summary is that NMOGA raised basically a question about the overall emissions reduction and a safety consideration, did it not?
That is correct.
And do you want to touch briefly on those two things?
Yes, that would be great. I've got a couple slides to support some of that, but the primary, can everyone see my screen? For some reason, it's not advancing.
I see a giant gray square.
Okay, let's try it again. Sometimes my dual monitors create havoc. Apologies.
Well, if you, okay, we can see it there if you can't.
I'm
Can you
not
just
sure.
from this
Okay.
slide? Good enough.
Playing with it.
We
I'll
lost
just
again.
speak to it. Okay,
Yeah, why don't you just speak to it? I don't know that we really need the slides for this.
you bet. So the recommendation was, at a minimum, was to strike the negative pressure requirements, and Ms. Keene and Mr. Palmer spoke upon that as well, and that being a safety concern, providing a opportunity for oxygen entrainment in your system by having a negative pressure system. So we appreciate that recognition to open up the method in which we collect the gas, not being overly prescriptive.
What's the concern with oxygen entrainment in control gas streams? Just for the board, they may not know what that means.
Absolutely. You know, the primary concern is you're introducing oxygen into a flammable product, as well as you do have oxygen specs that you're trying to maintain within your midstream provider in gathering service. And so you've got those two items that you're trying to balance out. But it's predominantly a introducing this oxygen in the explosive product.
So basically what we're trying to do is prevent it from exploding or catching fire. Is that correct?
That's right.
The other question I think that we had raised initially was that the initial estimates seem to be quite low. And you've heard now from Mr. Palmer that they believe it's about 5,000 tons. Do you have any initial thoughts on that revised emission estimate?
Yeah, obviously that changes the comment of significance. It was based upon an ERG memorandum that lined out, and that was one of the tables I wanted to share on the screen, but that's okay. That lined out what the compressor seal estimated VOC emission reduction would be, and the total gross VOC tons per year being 13. And so that is a significant departure from 5,000. So that was what the testimony of striking the entire rule from the proposal. The other reason being that it's not common practice to collect gas from reciprocating compressor seals. And so there's not an industry standard for the implementation. And because of this, the operators would just elect to maintain their Quad OA requirement of replacing the packing every 26,000 hours or 36 months, whichever one is first. And, you know, in my former midstream or upstream company, our compressors were located in buildings. And so venting gas creates high fire risk in the buildings, as well as causes a lot of nuisance alarming in our gas detectors. And so maintaining those seals was always part of our common practice, just in terms of keeping, at a minimum, the gas detectors from going off errantly.
So basically, in your view, we're not going to see a big amount of gain here because industry already does these practices anyhow.
That would be my feeling, yes.
Okay. Other than that, we don't have any substantial objections to the rule as revised by the department, correct?
That's correct.
Okay. I don't believe that we have any other questions for this witness, Madam Hearing Officer.
Thank you. Will we hear next from IPA&M or Kinder Morgan?
I believe that there would be first cross if anybody wanted to cross Mr. Lazowski.
I'm sorry, Ms.
And-
Katz, you're right.
Madam Hearing Officer, tonight, just to give you an indication, we do not expect to present Mr. Brown. His testimony was on section 112, and that's referenced throughout. So he was only listed because 112 is listed in that subsection. So Mr. Brown's testimony is complete, and he will not be testifying on the individual subsections here.
Thank you very much. All right, so if you would please turn on your camera if you're a party and have a question of Mr. Lazowski. No? I'll turn to the board while I'm doing, oh, no, wait, I'm sorry. We're holding off on the board. So thank you, Mr. Lazowski and Mr. Heiser. Let's go to Kinder Morgan. Ms. Gutierrez?
She's on mute.
Muted.
Sorry about that. I'm on mute. Too many devices here. Thank you. We have Mr. Vincent Brindley. Let me just get my, if I could just briefly share the screen.
Okay, hold on.
And as we're doing that, I just wanted to follow up on Chair Sweeney's question. We did have a look into the data points, and Chair Sweeney, Kinder Morgan operates 22 transmission compressor stations in New Mexico, and 13 of those would be subject to the proposed rule. So it's a particularly important provision, which is why we spent some time discussing that with you today. Okay. Okay, do we see compressor seals?
We do now.
Thank you. Mr. Brindley, as your qualifications have already been presented to the board, can you please introduce yourself for the record?
Sure. My name is Vincent Brindley, and I am a technical supervisor for Kinder Morgan.
Did you submit written direct technical testimony at Exhibit 9 and written rebuttal technical testimony at Exhibit 14 regarding compressor seals?
Yes, I did.
Do you have any changes to that testimony? And if not, do you adopt your written testimony here today?
I have no changes, and yes, I adopt my written testimony in full.
Thank you. And can you please briefly describe your testimony regarding the proposed VOC standards for compressor seals?
Yes, of course. Good afternoon, Madam Chair, board members, and Madam Hearing Officer. Originally, I had planned to discuss the topics as shown. However, in the effort to streamline these proceedings, I'll limit my testimony to expressing that Kinder Morgan supports the department's September 16th draft language. The department has removed transmission compressor stations from the applicability of Section 114. We support this change because it reflects that the VOC emissions from wet compressor seals used in the transmission segment are very low, and relative to those minimal emission reductions, the cost to control or replace these seals would be unreasonably high. With that, I offer myself for any questions from the board or other parties on the information in my testimony.
Thank you, Mr. Brindley. And I think we're just open to other parties at this time since we're doing board questions in full, but thank you.
Correct. Sorry.
All right, thank you. If you're a party with a question, please turn on your camera. All right, I don't see anyone. I believe, though, that with Mr. Brindley, we have everyone who would be questioned collectively on Section 114 completed. So, board members, this is the first time we're doing this, but we're going to do it 6 or 7 more times. We've heard the department's testimony. We've heard testimony from Kinder Morgan and from NMOGA. All of those witnesses who testified on section 114 are now available for your questioning. Madam Chair, start with you.
And really quickly, Madam Hearing Officer, I would just ask that Ms. Keene and Mr. Palmer turn their cameras on for questioning. Thank you.
Sure. Oh, and by the way, if you're on the platform as an attendee and you have a question, please reach out through the chat. Madam Chair?
I think if I'm correct, all the parties seem to be in alignment with the proposed rules from the September 16th. Is that correct?
That's correct.
Okay, well, I don't have any other questions at this time. Thank you.
Thank you. Vice Chair Trujillo Davis?
I echo Member Sweena's question, and so I don't have any questions.
Thank you. Member Cates?
Same here, no additional.
Thank you. Member Bitzer?
Couple of questions real quick. One, I did the math on 36 months of 24-hour a day, 365 day a year running of the machine, and it comes out to about the same number. Is there some reason it was 36 months or 26,000 hours?
I can answer that.
Not just every 26,000 hours, please.
It's to take account for those compressors that don't operate full time. I think you heard from Kinder Morgan that some of their compressors operate quite less than full time. So you could go 26,000 hours and not have to change them at 3 years. You could stretch it out to 5 or 6 years, I guess.
Okay, and that's too long. It's like an aircraft engine. You got a certain number of hours on the engine before you got to tear it down and rebuild it. But if the aircraft is run once a week or if it's run every day, it's still those air hours that matter. I guess it's different for this type of equipment then.
No, it's whichever one.
Time and tide.
It's whichever one is longer.
Okay. The other question I had was, what's the role of a fuel cell in this process? I mean, I understand a fuel cell can power a Honda Clarity or the Apollo spacecraft and so forth, burning hydrogen. But what is a fuel cell's role in this process?
That's a placeholder if that technology becomes available. So there was a menu of options, and fuel cell was included as a placeholder if it becomes available. That's the best I can say.
I tried before I got my Honda Civic that runs on natural gas. I tried to get a fuel cell powered vehicle out of Honda. They run something out of LA where they'll lease it to you, but they wouldn't turn me loose with one. I think because the membranes don't behave well at freezing and below temperatures. The membrane that requires the electron to go around. But anyway, those are the only questions I had. Thank you.
Okay, thank you. Member Garcia?
No questions, thank you.
And Member Honker?
I do have a couple for Ms. Keene, I think. You said the 95% control requirements, I believe you said were from the NSPS, is that correct?
Yes, Member Honker, that's correct.
How is that calculated? 95% of what?
So the calculation to determine control efficiency assumes 100% emissions, and then you assume a certain capture efficiency of those emissions and then a certain control efficiency of the control device. And so it's the combined capture and control efficiency results in a 95% reduction of emissions. And that is calculated by the efficiency of that system to capture those emissions, and then the efficiency of the system to control those emissions.
Okay, so it's basically 95% better than if it was just totally uncontrolled and vented.
That's correct.
Okay, all right, that's helpful. Thank you. No other questions.
All right, thank you. Let me ask if any of the questions prompted a need for follow-up by any council. No? All right, thank you very much, all you Section 114 witnesses. I see
Madam
Mr.
Officer?
Heiser. Yes?
I do have one issue before we completely depart from section 114. And that is that we just referenced the documents that were suggested by Mr. Palmer and Ms. Katz as being the source of the 5,325 ton estimate. We don't see any such information in those, but rather than, I'm sure they are probably correct, but rather than take the board's time, maybe we can just touch base with them offline. But if there's an issue with that, I guess I'd like to be able to come back to it. I think they're probably right, but we just didn't see it in the exhibit numbers they referenced.
Okay. I see Ms. Katz and Mr. Palmer nodding.
Okay, thank you. And I'll
Yes.
reach out after the hearing to Laura to figure out how to do that. Thank you.
Yep.
Thank you. Are we moving then to section 115?
Yes. So this is topic number 26 on the spreadsheet. And this is section 20.2.15. And then there are several associated definitions and proposals associated with this section. So I will call Ms. Keene and Mr. Palmer for the department. And Ms. Keene will need sharing privileges. All right. Sorry. So Ms. Keene and Mr. Palmer have both already adopted their testimony on this section, and I don't believe there are any changes to that testimony. So we will move right into the rules, to the discussion. So Ms. Keene, can you discuss the equipment and processes that are the subject of this section?
Yes. This subsection, or this section rather, 115 covers control devices and closed vent systems that are used to comply with the requirements of this part. A control device and closed vent system is a means to capture, convert, destroy, or recover air contaminants. The purpose is to reduce emissions of VOCs and NOx. Control devices include open flares, enclosed combustion devices, thermal oxidizers, vapor recovery units, fuel cells, condensers, and catalytic converters, as well as other technologies that may be approved by the department. The closed vent system is a system that is designed to capture and route VOC emissions from a source to a process stream or to a control device with no loss of VOC emissions to the atmosphere.
And can you provide the overview of this section of the rule requirements?
Yes, this section establishes operational and performance requirements and standards, monitoring and other requirements for both control devices and closed vent systems. It requires control devices to be installed, operated, and maintained in accordance with the manufacturer specifications. It requires that these control devices be effective, and that means that they must be sized adequately to handle the expected range of the emission stream to which it is controlling. This section also requires monthly inspections of control devices and closed vent systems to ensure that the units are operating properly, to check for leaks and defects and releases. This section also requires an assessment of the device to ensure that it's properly sized for that stream and that emissions are properly routed to the control device or process. And it also requires that an assessment be conducted by a qualified professional or engineer or an in-house engineer, and that that assessment be certified to the adequacy of the design.
I'll just let you move on to the various control discussions.
So this section breaks out specific requirements for several types of control devices. Open tip flares are one such device where there are very specific requirements established. The section requires that flares be properly sized and designed to ensure proper combustion. And that combustion must be maintained when gas is sent to the flare and for the duration that gas is sent to the flare. It prohibits gas being sent to the flare that is in excess of the design capacity of the unit. And it requires that all new and existing flares be equipped with a system to ensure that the flare is operated with a flame present at all times when gas is being sent to the flare. It requires that those units be inspected to ensure that a flame is present upon initiating of a flaring event for certain types of flares. It requires that the flare be equipped with a continuous pilot flame upon startup. And it requires that for existing flares controlling a continuous gas stream constructed before the effective date of the rule, that unit be equipped with a continuous pilot no later than 1 year after the effective date of this part. In addition, existing flares located at sites with low production must be equipped with an auto igniter, continuous pilot, or alarm that alerts the owner or operator of a flare malfunction if that unit is replaced or reconstructed after the effective date of this part. It requires that flares be operated with no visible emissions, and it requires that flares be repaired within 3 business days of alarm activation. The next set of requirements refer to the enclosed combustion devices and thermal oxidizers. These types of equipment and control devices are enclosed ground level combustors or oxidizers. There are many of the same requirements in this section as there are for flares. There are very similar monitoring, record keeping, and reporting requirements for this equipment. And I'll go through those revisions when I get to the red line strikeout version of the regulation. This section also contains very specific requirements for vapor recovery units. These are process equipment or control devices that route vapors from a source back to a separator, a sales gas line, or to a process line for beneficial use, such as a flare or such as fuel. we'll speak to the distinction between process VRUs and control VRUs later on. We've received comments about that issue, and I think we've clarified that the use of this VRU as it's intended to be referred to in this rule, and so we can speak to that issue if we need to. A vapor recovery unit is often referred to as a compressor that is used to boost recovered vapors back to the sales line. In a typical VRU application, the hydrocarbon or VOC vapors are drawn out of the storage vessel under low pressure and piped to a separator or other scrubber to collect any condensed liquids, which are then recycled back to the storage vessel.
So I'll turn over to Mr. Palmer to discuss the basis for the requirements in this section and the estimated emissions reductions and costs. So Mr. Palmer.
So the basis for the requirements in this section come from these 4 documents. The Pennsylvania General Permit, GP5 and GP5A, Colorado Regulation 7. It has a separate section for control devices. The NSPS subpart Quad OA, which is the 2016 NSPS or 2015, I believe, NSPS for oil and gas operations. And then also within the general provisions of the NSPS program, subpart A in the NSPS program. So as far as emission reductions and costs estimates specific to this section of the rule, we did not estimate separate costs or emission reductions for these control device requirements because those costs and reductions are estimated separately for each emission source using those controls and are estimated for that particular section of the rule. So there are no separate ones for these general requirements.
Thank you, Mr. Palmer. And turning back to Ms. Keene to discuss the definitions from section 7 of this rule that are associated with the control device section.
Yeah, so we have 3 definitions that we wanted to discuss as part of this larger discussion on section 115. The first definition is closed vent system, which is defined as a system that is designed, operated, and maintained to route the VOC emissions from a source or a process to a process stream or control device with no loss of VOC emissions to the atmosphere. There was an issue that was raised by commenters about the statement that there shall be no loss of VOC emissions to the atmosphere. This language is consistent with the federal New Source Performance Standard, Quad OA, and so the department intends to keep this definition in line with that federal definition. The second definition is control device, which I won't belabor here before you. We did receive a request from stakeholders to strike air-fuel ratio controllers from this definition. The department agreed with that request, as it did not intend to regulate air-fuel ratio controllers as control devices and didn't conduct any type of technical or regulatory analysis on that as if it were a control device. So the department agrees to that deletion. There was a requested addition of this definition of vapor recovery control unit to distinguish between vapor recovery units that are utilized in a control application versus a process application. The department does acknowledge that it can be used in both types of situations. However, does not agree that this additional definition is necessary to distinguish between the 2 types of applications. We have met with stakeholders and shared our intent, and we think that the revisions made to the rule address that comment satisfactorily, and that this additional definition is unwarranted and unnecessary. And just for the board's benefit, the department intends to regulate only those vapor recovery units utilized to meet the emission standards under this part within within section 115. And so process VRUs are not regulated under section 115.
And Ms. Keen, just to clarify, it was NMOGA that proposed this definition?
Correct.
And the definition that's indicated in green on the slide is NMOGA's proposed definition that the department has not accepted into the rule, correct?
That's correct.
Okay, thank you. So Ms. Keen, if you want to go ahead and summarize the provisions of the rule itself and and more to the point, to the revisions that were made.
Sure. Thank you. So before you is the standard format or framework that we have developed in each of the sections. We have 115 paragraph A is the applicability section. And then in fact, the title of the section as well, we received requests to insert and closed vent systems within both of those paragraphs, and we agreed with those additions. Within the general requirements, again, which is paragraph B and subparagraph B2, we received a request to insert that language, the reasonably expected range of inlet VOC or NOx concentrations or volumes, in lieu of fluctuations in emissions of VOC or NOx, and the department agreed that that was a reasonable revision to the language and didn't change the intent. We struck the requirement to install an equipment monitoring tag. We received requests in paragraph 3, which is the requirement to inspect control devices monthly. We received some requests for some minor revisions that we felt were in line and appropriate to clarify this requirement, and those revisions are before you. Again, they didn't change the intent. They strengthen and clarify this section, and so the department agreed with those as well. Paragraph 4 contains a revision that we think also clarifies that not all emissions can be prevented during the capture and routing of VOC emissions, and that the clarification to minimize venting of unburnt gas to the atmosphere was appropriate. And there were other minor clerical kind of editorial changes that were made that didn't change the intent of the language. So continuing on, this is the requirement to have the closed vent system reviewed and certified by a qualified professional engineer. We received requests to clarify that it's the assessment that will be certified by the qualified professional or in-house engineer, and the department agreed that that was an appropriate change. We also received requests to strike design and capacity. We also agreed that that was not necessary in order for the in-house or professional engineer to conduct the assessment of the system and to sign off on that assessment. There's several changes to paragraph 6. The department agreed with those changes as well. This information has been kind of repackaged. So the information that was previously in subparagraphs A through E have been repackaged into a single line in paragraph A. And so we have just kind of listed those requirements out instead of listed them out in a single requirement instead of fleshing them out in individual requirements, and agreed that those were appropriate. We made one minor edit here to clarify that the flares shall be properly sized and designed to ensure proper combustion, and we think that was a valid edit to make. The rest of the requirements are items that I've already spoken to, so I won't go through those again. These establish the basic operational requirements to maintain and operate the flare.
And just to clarify for the board that this particular section contains several paragraphs dealing with the particular control devices. So this is the one for the flares, correct?
That's correct. Thank you. That's a good point. So we are departing now from our typical framework that you have seen in other sections, and we have different paragraph letters for flares, enclosed combustion devices, and vapor recovery units, which you'll see. So there are different types of requirements depending on the type of flare, which I spoke to previously, and there's also different types of requirements if that flare was located on a small production site, and these edits were made to align with the OCD's regulations, so that there's some alignment there between those two requirements and no duplication or contradiction between those requirements. We received so I'm not going to go through and read all of these in detail, but if anyone has any specific questions, I'm available to ask or to answer questions. Paragraph D before you, edit was made to clarify that observations of the visible emissions may be terminated if the evidence of a visible emission was observed and recorded. An action is taken to address the visible emissions, and the department finds that reasonable. If an owner operator is addressing the visible emission, there's no need to continue to conduct a 15 consecutive minute visible emission observation in order to demonstrate that there were emissions observed. We also clarified that flares shall be repaired within 3 business days of a thermocouple or other alarm activation. And the final language at the bottom of 2C here formalizes the edit that was made above in paragraph D. So again, that monitoring of the visible emissions doesn't have to be continued if the owner operator takes initiative and observes and records, and action is taken to address the visible emission. So these are continuing on with the monitoring requirements of the flare. The EMT tag requirement was deleted and replaced with a date and timestamp of the monitoring event. And then subparagraph 3 are the record keeping requirements for the flare. Again, we made minor editorial changes here that were discussed previously. So this is aligning with the language of the requirement. And this additional changes, there's not substantive edits made here in any part of this section. So we're now to the requirements for enclosed combustion devices and thermal oxidizers, which are essentially identical to the open flare requirements. And so many of the edits made here are similar to the ones that were made for the flare section. So the language that it be properly sized and designed to ensure proper combustion efficiency is identical to the change made to the flare section. We've added clarifications when those units have to be equipped with a continuous pilot or an auto igniter. So new units need to have that kind of technology upon startup, and existing units have 2 years to comply with that requirement. And again, in paragraph D, language was added so that a visible emission observation can be concluded if an owner operator records and takes action to address the visible emissions. This slide contains the monitoring requirements for the ECD and thermal oxidizer. Again, that added language in B is formalizing that requirement that I just spoke to. There were other very minor editorial changes made here that didn't change the intent of the language and was acceptable to the department. Subparagraph E or paragraph E are outline the requirements for vapor recovery units. Paragraph 1, A and B speak to the emission standards or the operational standards for these units. The insertion of this language in 1B was important in that there are air permits that have been issued that don't require redundant VRUs to be brought on site during VRU downtime. And so this aligns with those existing air permits. And the department found that was reasonable. It is only applies to existing air permits that were in effect prior to the effective date of this part. So there is a sunset clause on that provision. And also we've added in an option that alternatively, and this was based on a request from stakeholders, that the owner or operator may shut down the unit being controlled by the VRU. And then also for sites that already have a VRU installed as of the effective date of this part, it gives a longer compliance timeline to install backup control devices. And that timeline has been extended to 3 years, which the department also finds reasonable. So these are the monitoring requirements of the vapor recovery unit section. There have been not many substantive edits here made at all. These are clarifying edits that don't change the intent or purpose of the requirement. They formalize revisions that have made in previous subsections. And so there's no new requirements. That was the end of that ended very quickly.
Madam Hearing Officer, that concludes the department's presentation on the control devices section.
Thank you very much, Ms. Katz and Ms. Keene. If you are a party with a question of Ms. Keene, please turn on your camera. I see Mr. Heiser.
Thank you, Madam Hearing Officer. Thank you, Ms. Keene, for your testimony on the control devices provision. I have a few questions, and I don't know if it'd be easiest to maybe have you bring slides up so that we can talk about at least the first two. Those are on that definition slide.
Sure.
Perfect. So my first question is in the definition F for closed vent system. And I know that you testified that there should be no loss of VOC emissions to the atmosphere. But I was wondering if you could explain how an operator is supposed to do maintenance work on a closed vent system without having a loss of VOC emissions when you have to open the system in order to work on it.
Yes, and so we have aligned this definition with the federal definition, which also states no loss of VOC emissions to the atmosphere. And so I think we can be in agreement that during maintenance, there's going to be some maintenance emissions associated with the venting. But that it shall be, when it's operational, during normal operations, the expectation is that there shall be no loss of VOC emissions.
I believe industry would be very supportive of no loss during operation. Our concern has been really more the maintenance and the unavoidable issues if you have to open. So I appreciate that clarification. And then in subpart TT, you talked about the vapor recovery control unit. And I just wanted to confirm that the department, by including vapor recovery units in the definition of control device, was not trying to adopt a global determination that all VRUs are now control devices. Is that correct?
Correct.
And so where there's already been work done between you and an operator as to whether a specific VRU is a process or a control device, that prior determination would still remain in effect for them. Okay, thank you. That's very useful as well. A couple of other things then, and these slide through the slides, but perhaps maybe we can go to section C. One of the questions that we had, if you look at C1B, and then there's 4 little Roman numerals, I guess we call them Romanettes underneath it. In Romanet 3, maybe it's 4, some of these have effective dates and some of them don't. Could you walk through the effective dates that the department is looking for? Because there seems to be variations between continuous and non-continuous flares. So we weren't sure what your thoughts were for the non-continuous flares.
Yes. So the so paragraph C1B1 states that a flare with a continuous pilot flame or an automator shall be equipped with a system to ensure the flare is operated with a flame present at all times when gas is being sent to the flare. And so is your question?
So yeah, is that immediately upon the effective date, or did you intend that there be a period of time to make that occur?
There should be yes, we can certainly work with clarifying compliance deadlines for that.
But in general, your thinking was a year for most of these flare provisions on existing?
It was a year for most of the existing flare requirements.
That's what we understood, but it was a little bit hard with B to quite follow it through all the way. Another question that had come up is there's a requirement, I believe it's here in the open flare, that says that we have to have a flame present at all times when gas is being sent to the flare. And because we're industry and because we're hyper cautious, we just wanted to be certain that there was no disagreement that if there is a little bit of gas prior to the first spark from the auto igniter, that that was not what you were contemplating as a violation of C1BI.
No, that's not what we intended.
Yeah. Then in C1, I think it's E, if we can go down just a couple pages. It talks about here, the owner operator shall repair the flare within 3 business days of any thermocouple or other flame detection device alarm activation. Could you explain a little bit what the department's expectations are if we believe it's a false alarm or a failure of that monitoring system?
So, I'm sorry, so your question is how would we
How do we
handle a
handle
situation if there was if it was an issue with the alarm itself and not the flare?
Correct.
Okay, so I think that needs to be documented, of course, that there was an attempt made to repair the flare and there was indications that the flame activation itself, the alarm activation itself
So we could just
not
document
functioning.
that it basically that it was a false alarm and the flare appears to be operating appropriately.
Correct.
Okay, thank you very much. Let me check my notes here. And then in a couple of places, you refer to an expected range and properly sized as it relates, I think, to flares and enclosed combustion devices and thermal oxidizers. And by that, are you expecting the designer to use professional, appropriate professional engineering judgment to determine what that appropriate sizing is, as opposed to, say, instantaneously everything that could potentially possibly go into the system dumping at that same instant second.
The reasonably expected range should be, well, the unit needs to be sized for the emission sources that it is intended to control. And I think that would be kind of an unusual event to have everything dumping at the same time. I guess I would need more information about what that event was. If that was the normal mode of operation, then the unit should be sized for handling all of those streams consecutive or simultaneously.
And so I think the issue arises, and that's a really good question back on your part, because obviously it's different if you have one unit, one control device, but as I think we've heard testimony, sometimes there will be many units that go to a single control device. And so there may be quite a number of potential inflows. And so in that latter situation, that's really where we're starting to look more at the use of engineering judgment to balance the fact that there are multiple flows that may or may not be going on at any one time going to that control device.
Yes, I'm not sure if you have a follow-up question for me.
Okay. So would that be the type of situation where you would expect the design engineer to exercise that judgment on what is reasonably anticipated or reasonably expected range of inflows?
Yes, and I would qualify that if it's expected that all of those emissions occur simultaneously, then the unit should be sized to handle that flow.
Okay. Thank you. That's all my questions.
Thank you. Are there any other parties with questions of Ms. Keene or Ms. Palmer? Let's see. Not seeing other parties turning on their camera. As I read across the spreadsheet, I see that Oxy had proposed a witness Holderman. Is that still true? Mr. Jano?
Yes, yes, Madam Hearing Officer, it is.
Okay. So shall we take Mr. Holderman next?
We are ready if the hearing officer is. So,
Absolutely. Mr. Holderman, if you would turn on your camera, please.
we'll be swapping out again, Madam Hearing Officer. I thought I'd give a quick little intro on what Mr. Holderman will be talking about. We will swap out. Forgive us if we still haven't found a better solution even over the weekend as we were looking on the IT side. So I hope you will indulge us yet again.
Yeah, well, that's great. 2 for 1 on a screen. That's great. All right. Mr. Holderman is still under oath.
Yes. So Mr. Holderman will be speaking to you one very specific issue that has not otherwise been resolved in the September 16th changes that were made by the agency. Specifically, it relates to section 115E1B and the implementation schedule for redundant backup control devices and vapor recovery units. The revisions that were made by the agency extended that time period from no specified time period to a period of 3 years. And Mr. Holderman will be testifying about why 5 years would make sense in that context. So I will turn this over to Mr. Holderman. So Mr. Holderman, if you would explain to the hearing officer and the board why it is that 5 years as opposed to 3 years would make sense here.
Sure. Let's get down to the business. When we looked at this, and has it been acknowledged by the parties on all sides in the proceedings, the various board members, pretty much everybody that we've heard, retrofits that will be required based on the size of the number of wells, et cetera, in New Mexico will be substantial. Our concern is that steel shortages, component shortages, lack of skilled manufacturing labor, limited manufacturing capacity, lack of skilled installers, and other supply chain issues, as well as the growing demand for similar equipment in other states, will all limit the ability of operators to timely meet the retrofit and installation requirement of the rules. It could take years for manufacturing capabilities and the labor force to scale up to necessary levels. And even if manufacturing capabilities are ramped up, we still need the skilled personnel to install and maintain the equipment. When all operators statewide begin taking similar steps to come into compliance with these rules, all of these issues will come to bear. At this point, there's simply not enough manufacturers, technicians, or laborers to meet this demand in the proposed timeframe. Put it in better context for VRU specifically, control device manufacturers have estimated during recent discussions that the market as a whole can produce up to 500 VRUs in a year, which is not enough to meet the substantial demand increase, or excuse me, the substantial increase in demand triggered by the rule. This is why Oxy believes it's critical to provide additional phase-in time that accounts for the realities of these resource restrictions. Without meaningful additional relief on these deadlines, Oxy and other operators run the risk of becoming out of compliance for reasons that are completely out.
Mr. Holderman, you had mentioned about sort of the capacity in the market, just to give the board a little bit of an idea of what that means. How many VRUs can be manufactured in a year again, sir?
500.
And Oxy would need approximately how many to meet the requirements of this rule?
We've estimated so far that we would need between 150 and 200 VRUs for the 2,700 wells that we operate in the state, just to come into compliance. That's not including the additional VRUs we would need for our normal.
And Mr. Holderman, approximately what percentage of wells in New Mexico are Oxy wells?
My best estimate of that one has just been by the information here. So I think that we've heard that we have somewhere between 54 and 55,000 wells. As I said, Oxy, the actual number is 2,745 that we operate. So we operate roughly 5%.
No further questions on direct from Mr. Holderman. We present him for cross.
Thank you very much, Mr. Dano and Mr. Holderman. If you're a party with a question, please turn on your screen, Ms. Katz.
Thank you, Madam Hearing Officer. I just have a quick question. Mr. Holderman, the numbers that you're talking about how many VRUs can be manufactured, do you submit any evidence of that for that number, or any data for the basis of that?
The data came from conversations with our suppliers, and it's submitted in my direct testimony.
As there's exhibits into the testimony?
Yes.
Okay, thank you.
Okay, thank you. Any other party with a question? Turn on your camera. Not seeing anyone. Thank you very much, Mr. Holderman. The questions from the boards will come up in just a little bit. Does GCA still intend to present witness Philby?
Madam Hearing Officer, Mr. Philby's direct written pre-file testimony, which is GCA Exhibit 23, addressed the GCA's proposed amendment to the department's proposed control device inspection schedule as set forth in the department's May 6, 2021 proposed rule at sections 115B4 and 113B2. The GCA was particularly concerned with the requirements of the proposed rule as they relate to catalytic converters, an important emissions control device for compressor engines, and that the monthly inspection requirement could be interpreted to require unnecessary and potentially counterproductive physical inspections of catalytic converters. I am happy to report that since that time, NMED has addressed the GCA's concern with sections 115 and 113 in NMED Rebuttal Exhibit 23. Given the cooperation and in an effort to streamline this proceeding, if parties or board members have questions for Mr. Philby, he is actually unavailable this afternoon, but he is available to appear Thursday or Friday. Otherwise, the GCA is satisfied with the admission of Mr. Philby's resume and testimony, which have been marked GCA Exhibits 23 and 24 respectively, into the record, and as support for sections 115B4 and 113B2 as set forth in NMED Rebuttal Exhibit 23.
Thank you very much, Ms. Shan. Let's see, does Namoga intend to put on witness Meyer?
Yes, Madam Hearing Officer, we do.
All right, thank you. Mr. Heiser, go ahead.
So as it's Adam Meyer, should hopefully be a panelist. And he will need presentation rights at the appropriate time.
Terrific.
Yes, I'm here. Can you hear me?
Yes.
Okay.
Madam Hearing Officer, he has not yet been sworn, so you might like to do that.
That's right. Would you spell your name, please, Mr. Meyer?
Adam Meyer, A-D-A-M. Last name is Meyer, M-E-Y-E-R.
Thank you. Would you raise your right hand? Do you swear or affirm to tell the truth?
I do.
Thank you.
And Adam, you should be able to share your screen.
Okay, thank you. Let's try this out. Everyone see that?
We can see it. Can you make it bigger?
Let's do presentation mode. How's that?
That's very good. Thank you. Mr. Meyer, could you state what your involvement is in this proceeding?
Yes. My involvement in this proceeding was to coordinate the Valor EPC team, as well to provide technical testimony on various portions of the rule, including storage tanks, control devices, and pneumatics, to name a few.
Okay. Is Namoga exhibit number 30, which was previously admitted, an accurate copy of your resume?
Yes.
Could you please state your qualifications as they relate to your participation in this hearing?
Yes. So I hold a bachelor's of mechanical engineering from Penn State University and a master's from the University of Florida in thermal fluids transport. I've been designing facilities, piping facilities for almost 20 years, various different industries. I started with electric boat building submarines. So doing a lot of piping systems, propulsion systems for that capacity. I worked at Kennedy Space Center, Florida, where I was a thermal fluids engineer and cryogenics specialist and all other gas type of facilities. Did that for 8 years. I've worked in gas turbines, balance of plant systems for Siemens Westinghouse. And in the past 8 years, I have been in oil and gas doing upstream and midstream production facilities and midstream facilities. I would say in the past 7 years has been my focus has been facility design for emissions reduction and compliance. And that actually extends to a lot of different disciplines. More specifically, I'm probably more well known for my work in storage tanks and vapor control systems. Myself and my team have evaluated over 2,000 tank batteries in that time. And many of the terms that we are using today were coined by myself and my team.
Thank you. Do Namoga exhibits A2 and 42, which are previously admitted, reflect your direct rebuttal testimony filed in this matter?
Yes, they do.
Okay. And for the board, that means A2 and 42 will be where you'll find Mr. Meyer's direct testimony. Do you adopt that testimony as your testimony here today?
Yes, I do.
And then did you rely on various facts and figures in Namoga exhibits 10 through 21 as you were preparing your testimony?
Yes.
Have you provided a summary of your direct and rebuttal testimony?
Yes, I have provided a summary for my rebuttal today as it relates to control devices.
All right, well, let's then go through that summary for the board, please.
Okay. In the context of the control devices discussion, like I said, was part of many portions of this rulemaking, so I'll keep it just to the control devices for now. Part of my rebuttal testimony was to provide a little bit of clarification for some of the red line justifications as it pertains to capture of 95%, and design efficiency for 98% of combustors. And what I'd like to do is just as part of the rebuttal was to go through what we on the engineering on the ground floor, how we evaluate and how we size these control devices. So in this first PowerPoint, what we do when we are evaluating a facility and sizing a control devices is we start with a process simulation of usually of the entire facility, and through that we're performing a sensitivity study regarding what flow range we need to operate, pressure and temperature range, and the kicker, which is our composition of the gas that we are trying to combust or flare. Part of this process is designing for normal operations or foreseeable processes and evaluating the turn down of those devices that we want. So usually you'll do this process simulation and you'll create a spec sheet that we provide to a combustor, flare, or VRU manufacturer that says, here's what we think the composition is going to be, and here is the process and pressure and temperature ranges it needs to operate in. So the key here is that going through all that, we have a design condition, right? And I want to talk about how design is different than operations, because our design is the full intention to capture all vapors off of tanks or other processes and to combust them efficiently based on what we know of the composition.
And then before you depart that slide,
Sure.
You had a reference to something called turn down, and I think that may not be a term that's familiar to the members of the board. Maybe you could spend a moment talking about what turn down is and why it's an issue.
Okay, so good point. So turn down is a piece of equipment's ability to properly operate through an entire range that is being demanded to operate it. So I think a lot of people are familiar with the term PPIVFR, peak potential instantaneous vapor flow rate. And there's a new one, which is the potential minimum instantaneous vapor flow rate. Those two terms, which may or may not be brought up in various consent decrees or negotiations, is an attempt to describe turn down. If I design a facility to process, or a flare to process 100 MCFD, million standard cubic feet per day, how efficient is it at 1 million standard cubic feet per day? So that turn down ratio is something that's very critical when we're designing a system.
And so basically what you want to do is design a control device that will operate at the optimal efficiency for the majority of time that it's operating, as opposed to the very long tails of how that device may be called upon to operate.
Exactly. What's more of a problem is that the demand of the range is becoming greater with a lot of rules that are coming out. Designing for a worst case event, as we call it, the 100-year flood event, where everything flows through the combustor at once, that means the combustor needs a huge demand, but normal operations is a fraction of that. So what you see is turn down issues in the field where we've oversized the equipment based on precedent set, and during normal operations, the amount of gas is not nearly that much. And so there's a potential turn down issue.
Why don't you move on?
Okay. So, again, we're talking about design versus operations. In operations, there's potential for unanticipated scenarios, flows, pressures, temperatures, even ambient conditions will affect will vary and beyond what we designed for. So, and then on top of that, there are potential for fluctuating compositions. So we design as best we can these control devices, or spec them out, I should say, But ultimately, during operations, there are a lot of unknowns. This especially becomes a problem with temporary flares, temporary equipment, where there's a massive hurry up to bring something out onto the site to control emissions to the best of our ability. But we don't have all these answers like gas sample, gas composition. We don't have time to go through that CVS closed vent system analysis or get it even certified, right? As would be required if it were classified as a control device in the context of this rule. So a lot of these temporary equipment, it's a minimizing to your best effort. I think Colorado coined the term maximum extent practicable. What we're trying to do is do our best to get emissions under control for these temporary equipment. And so part of that is we need to, my opinion is having a carve out, not only to differentiate between design requirements and operational requirements, but have a carve out specifically for temporary emission control equipment.
And so if I can back you up for just a second there to provide perhaps a scenario. So when you're talking about temporary emission control, would that be a situation where, say, a facility has a permanent flare and for some reason that permanent flare malfunctions and we're trying to input in its place a temporary flare to control the facility while we're working on the permanent flare? Is that what you're concerned about?
Correct. That's a situation that concerns me.
Why don't you go on to your next slide?
Okay. Kind of along the same lines of, I'm providing these pictures to show an example of the difference between no emissions and minimal emissions as it pertains to the definition of closed vent system. There are some situations that we just cannot prevent. So here's an example. The picture to the left is a pinhole leak created by a manufacturing defect in the casting. It was so small that no one could be able to see that when they were putting this in operation. The picture to the right is an example of a thief hatch, and this may be in the weeds, but you'll notice that the thief hatch on the left does not have a groove and the one on the right does. That is to illustrate that in that instance, the vacuum pallet on the thief hatch was shipped incorrectly assembled. And it was put in without a thought, but that created a higher potential of emissions from the thief hatch. And the last one I'd like to show is 100% capture is pretty impossible. And here's just an example of truck line connection and disconnection. There will be trace amounts of VOCs that get emitted during that time. We can design, as best we can to minimize emissions, but there'll always be a little bit. And so we want to tailor the rules to as a best effort to say we want to minimize emissions to the maximum extent we can. That concludes this section.
So if you were to be making a recommendation to the board and to the department, would one of those things be that, for example, where there is the very detailed CVS assessment requirement, that may not be appropriate for this temporary equipment where you're bringing it in, for example, where the main flare went down and you're trying to put a temporary flare in that situation?
Yes, I think the rules need to have a carve out specifically for those situations.
Okay, thank you. That's all my questions.
Thank you, Mr. Meyer and Mr. Heiser. If you would stop sharing your screen briefly.
Okay.
Are there any parties who have a question of Mr. Meyer? Please turn on your camera. No. All right. Let's see.
Madam Hearing Officer,
Ms. Katz.
I was going to make the point with Ms. Keen, but I think I'll just do it with Mr. Meyer for the interest of time because it's easier. Mr. Meyer, do you know if NMOGA has proposed any language to address your concerns regarding use of temporary control devices in cases of malfunctions or emergencies like you have testified about?
If I recall, there was an attempt to exclude temporary. I think more work needed to be done to define it, and maybe that's where we haven't quite aligned on it yet. So to my knowledge, that's where we left it.
Okay, and the department would be amenable to considering that language and to working on that to where we can get to a acceptable place for both of us.
Okay, great. That'd be great. I'd be happy to help.
All right, thank you, Ms. Katz.
That's all I have.
All right, thank you. As I understand it, Mr. Rose indicated that Mr. Brown would not be presenting on topic 26. We've already heard from Mr. Holderman, and I understood an earlier email from Ms. Paranos to mean that Mr. Alexander would be testifying on section 117 and not 115, but let me see if I can get confirmation. Ms. Paranos?
Madam Hearing Officer, this is Rico Gonzalez on behalf of IPAN. Yeah, we request that our witnesses be here tomorrow.
Oh, okay. All right. So you will be presenting Mr. Brown on section 115?
Not today.
Okay. Thank you.
Thank you.
We may not have Ms. Paranos, but I understood her email to mean that Mr. Alexander would not be presenting on section 115, or rather section 117. All right, so I think at this point, we will ask all of the witnesses who've testified on section 115 to engage their camera so that we can turn to the board for their questions. While we're doing that, if you're an attendee on this platform and you would have a question, please reach out through the chat. So I see Ms. Keen and Mr. Palmer and Mr. Jano's witness. Let's see who else. And Mr. Meyer. All right. Madam Chair, do you have questions of the section 115 witnesses?
Yeah, and I think this is just a follow-up to Ms. Katz's question is, I think this would be for Ms. Keen is, what's been any discussion regarding the temporary, the language for temporary flaring? Has there been any consideration? And if there has been, can you just share with the board what it has been thus far?
Yes, Chair Sweeney. There was a request to simply exempt temporary equipment from the operational standards under the section. The department did not agree to exempt those temporary controls from the operational standards. But we are willing to consider a definition of temporary and find a way to come to an agreement on what standards would apply for those sources.
Thank you, Ms. Keen. And have any of the other, I know EDF had a witness. Has there been any other concerns regarding some of the language from some of the other parties other than the industry?
Madam Chair, let me look into that.
And Madam Chair, I'll just say that if if a party hasn't put up a witness on a certain topic or section, it's usually indicative that they didn't have specific concerns about that. But, and I don't know, I don't know if EDF's witness, I can't remember if he was supposed to testify on this point or a different one.
Okay, I just wanted to make sure. Thank you, Ms. Katz. I just wanted to make sure since I know EDF was listed as a rebuttal witness. I just wanted to kind of have an understanding if there was any other concerns. And then I think I have one more question for, I think it's Mr. Meyer. I know you had talked about some of these issues regarding temporary issues or temporary flaring that needs to happen. And I think you used the language, they were unanticipated, instances or situations. Is there do you have an estimate as to how often an unanticipated issue or situation arose, say, in the last year?
Oh, let's see. I'm sorry, I can't think of one off the top of my head of an unanticipated operation that, yeah, a lot of times it's associated with a malfunction, to be honest. However, I'm trying to think of a good example. It's not coming to mind. I may be able to put out some anecdotal to the group if that's of interest to people. But I think when Mr. Heiser is referring to, we're referring to temporary, it was to, you have a permanent in place flare combustor, and then the lead time to procure one in a quick order before this other one gets repaired can sometimes be very difficult, and we have to do whatever we have to do to to get it under control. So I think it really comes back to Ms. Katz's point, the how do we define temporary? And then I'll find some scenarios for us to talk about.
Absolutely. My background is in water, and so when you use the phrase 100-year flood event,
you get it.
I resonated with that, and so I was thinking, is it every 100 years? Is it every year? And so I just wanted to get some kind of idea of how frequent, this situation would arise.
Yeah, and I guess I couldn't answer that at this time.
Okay.
Thanks.
All right. Thank you so much. And maybe we're still here for a couple of other days. Maybe that information will be available later on.
Sure.
That be possible? Okay. Thank you.
Thank you, Vice
That's
Chair.
all for now.
Okay.
Madam Chair, if I could come back to your original question. So I went through our rebuttal testimony and I didn't see any of the other parties specifically commenting on that section. However, EDF's in their original proposal, they had included their flowback vessel requirements within section 115. They have subsequently moved those out of 115 into its own section.
Okay. Thank you for that, Ms. Keene. I appreciate it. Thank you, Madam Hearing Officer. That's all for now.
Thank you. Vice Chair Trujillo Davis.
Yes, thank you. And I'm going to skip around to a couple of different witnesses, but I'm going to start with Ms. Keene. I just want to say that one of the stronger points in this rule that I've seen so far was in the engine portion where there was effective dates and percentages for compliance, the 35% by a certain date and so on. And so I have to say, I think I echo Mr. Heiser's point when he mentioned that kind of was missing from other portions like the flare portion of it. So is there discussions? I think you mentioned that there would be some discussion on that, but I think that was a valid point. Can you expand on that?
Yes, Vice Chair Trio Davis, and we will go through and ensure that compliance deadlines are clear in each section based on that comment. That may have been an oversight, and we will go back and ensure that there's a clear compliance timeline for each one of those requirements. And yeah, and so I think a year would be reasonable. That is what we have established in other flare requirements. But we'll go back and ensure that that's as clear as it needs to be.
Okay, and yes, I don't have any thoughts on your time frame on that. I just thought it was a really strong point in the engine section of this rule. So that's all I have on that one. And then my next question is for Mr. Holderman. I don't see him on the screen. See there? Oh, sorry. It's the end of my screens over here. So in my experience, newer facilities are being built with 1 or 2 VRUs. So the numbers that you quoted for additional VRUs, was that to bring older facilities into compliance for the rule?
Yeah. So, I mean, I guess to give you notional numbers, so since 2017, we've built 31 facilities that average about 4 VRUs per facility. So each, with multiple royalty trains, et cetera, on each facility. So that 1 to 2 that you quote is accurate. So that puts us at 120 VRUs that we would buy for our development program. That's what I'm talking about. That equates to only about 300, 400 wells out of the 2,700 that we operate. So the additional 150 to 200 that I'm talking about is for the pre-2017 facilities that would require controls that don't currently have them. That's what I'm extrapolating.
Okay, I just wanted to be clear on those numbers. And could you give me those numbers just one more time?
So the notional feedback, and like I said, this is just conversations with suppliers, is 500. Again, we would need 500 per year. I'm sorry, that the market has. We would need 150 to 200 to come into compliance. Plus, like I said, what we would need for our development program. So maybe 250 in total over the 3 years that we're talking about. Because I just also want to drive home that when we're talking about this deadline, we actually fully support and are just trying to make sure that primary VRUs are available for those that need them. So the extension that we're requesting is only for the redundant VRU.
Okay.
Make sure that was clear while I had the opportunity.
So in my time out on the patch, we would run into problems with getting pipes sometimes overseas and things like that. Are these VRUs, do you know if they're made stateside, or are you looking at
They're both. So the manufactured components and the raw materials often come from overseas or the States. They tend to be assembled. So that's when we talk about manufacturing capacity. They're assembled in Oklahoma, Texas, New Mexico, various places. And then they're installed, obviously, and maintained here on site. And I mean, when we talk to those out there, raw materials are probably the second largest. The availability, though, of folks to actually put them together and do the maintenance, the skilled labor portion of it is where the biggest concerns seem to lie. Because I mean, in reality, you're talking about creating a significant demand over a 2 to 3 year period for compliance, and then the jobs would flatten back out. You know what I mean? And so being able to attract people to go through fairly rigorous training and commit to moving, et cetera, and then not have a long-term assignment or potential for a long-term position is what they're generally worried about. You will be able to transfer some of those folks to the field for installation, but that's not a guaranteed assumption because, like I said, there's a fairly big difference between being in the manufacturing facility and moving out. People is number one, raw materials are number two, and then there seems to be adequate manufacturing capacity. If we're able, I mean, that would be the third limit.
Thank you. My next question was going to be how long you thought this was going to be an issue before it resolved itself with demand. So I think that's all I have on that one. And so my last question is for Mr. Meyer. So thank you all for your patience. You were discussing the optimal operation for a VRU. And we discussed in previous conversations the higher end of that range, but I was wondering if there's a low end. So is there a bottom range where the VRU becomes ineffective?
Well, there's a lot of ways to handle that. You can handle, if I have to have an oversized VRU for my closed vent system certification perspective, right? There's ways you can offset it with makeup gas. That's usually the one way of doing it. So that way I can have a continuous gas feed slipstream coming from the upstream facility to the suction side of a VRU, right? And the gas just kind of gets recirculated, right? So adding these circulation loops is a good way of controlling it. VFDs, variable frequency drive VRUs are good. Those are much more expensive. So there's ways of handling the turn down with VRUs. I would say a lot better than a combustor or a flare. Combustor or flare, you know, if we're talking about tanks, right, the bottom end is, 1 to 2 ounces. But I have to keep that tank to below 16, 14 ounces. So that's my inlet pressure range. And then I have all these I have to design that flow rate of that combustor for a multitude of different flow scenarios and upset conditions. So it becomes, in my opinion, very difficult with a system that's strictly a flare or a combustor. VRUs, there's things we can do because we're not talking about efficiency in terms of burning. But flares, in my opinion, and combustors are much more difficult.
So just to help clarify it in my mind, but if you drop to the low end of that range in the current setups, I guess right now, if you drop to the low end of that range, do you have to go to flare or combustor?
If you're saying you're asking if the pressure at the inlet of a VRU drops, there's a lot of difficulties, right? It's not that a flare turns on and you divert it in that instance. What is a hazard potentially is oxygen entrainment through either thief hatches or honestly into through the pipe themselves. The suction right at the VRU is under great negative pressure. So there's a potential for atmospheric air to get in, right? Unless you properly design that right. So there are a lot of issues with dealing with that, and then ultimately, VRUs can go in recirculation mode, like I said, where they take the exhaust from the VRU and put it right back at the inlet. Well, then in that case, the temperature of the gas tends to rise until this thing shuts down on temperature. So there can be issues. There are more facility upgrades that are needed than just the VRU. A lot of the context of a lot of things Valor has done with this testimony is to kind of shed a little bit of light. Yes, a combustor costs this, but there's all these other facility considerations you need to look at that could increase the cost. I'm not sure if that answered your question. Sorry.
No, you're giving me a good picture of what's going on here. So as long as the thief hatches stay closed and oxygen's not being introduced from some other mechanism, your and the pressure doesn't get above or stays around 1 or 2 pounds, you should be able to operate that VRU 98% of the time. Okay.
I think doing testing right now. I'm doing testing where there's, we're tracking that a little bit more diligently than maybe has been done in the past. However, there is the occasional power outage that now your VRU's down and you have this tank full of oxygen from the air because it brought in oxygen at night. Now, how do you get rid of that? You have to, be careful about it. So staying in operation is actually not only critical from a business perspective of keeping the molecules flowing to sales, but also if you get in an upset condition, what do you do in designing the facility so that you can actually get back up and running quickly? So in terms of 90% of the time, to your question, I think it's a little too soon to answer that because of one, not all VRUs are the same. Not all systems are designed the same. Tanks, for example, can have a rating of 16 ounces or 4, right? I think I put this in my testimony where a lot of the issues we're seeing is a tank, folks are trying to control emissions, but the tanks are only rated for 4 ounces, and that's not a lot. Just to give everyone some context of what that means. If you were to take a gauge and blow into it like you're blowing a balloon up, you can blow 36 ounces. So 4 ounces is nothing. So it's very difficult to control tank vapors. And of course, this is all compounded by availability of the right equipment, right? So in terms of how often these things run or could run, I think it could be done depending on the facility and what's there already. That's all I can really say about that.
Okay, thank you for that. I appreciate you all answering my questions. I don't have any more.
Great, thank you, Vice Chair. We do need a break, and we do need 15 minutes. So what I'd like to do is come back at 5:10, and I will get on the platform just to tell folks present for the 5 o'clock public comment session that we're going to start at 5:10. Let's come back at 5:10, please.